Alrighty. I want to find C such that the mean value theorem is guaranteed. Now, first of all, for mean value theorem, it has to be continuous on the interval. Is it? Yes. So, the mean value theorem basically is saying we're trying to make, basically, hopefully you know that cosine graph. Does cosine start at 0 or at 1? Cosine of 0 is what? So this one starts here and it goes like this. But isn't it also going like this? Basically it goes boom, 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 boom. Now we want it for this interval. And what it's saying is I want to find for this interval a rectangle that matches the area under the curve for that interval. So say that interval is this, which I think it is, something like that. It wants to then, for this interval, find an area that matches the area of the under the curve. And then it wants to find where do you, at what C values do you get that rectangle, the height of the rectangle. The way we do that is we're looking for f of C as the first step. You multiply f of C by b minus a. This is a, this is b. So it's going to be pi over 3 minus a negative pi over 3 equals the integral of from a to b of f of x dx. So this is what we're solving for. We want to first find f of c. F of c times b minus a, that's the area of the rectangle. F of c is the height. B minus a is the width of this rectangle. This right here is the area actually under that little curve. These should be equal. So when we can solve both of these, we can find f of c, but then we want to find c that gives us f of c. So we now have f of c equals, looks like this will be 2 pi over 3. Is that right? Not equal, sorry. Times. Is that right? Yes. Equals, well, the integral of cosine is what? Positive? Yes. Positive sine. And our interval is from negative pi over 3 to 3. When you calculate this, you now get f of c equals, I'm not doing equals yet, let's keep the equals out still. Sine pi over 3, this, what do you get when you do all this right here? Don't you get square root 3? This whole thing ends up being the square root of 3. I'm saving time. If you were to plug in this and subtract the 2, you get square root 3. Sorry, I skipped a step. But again, if you plugged in this and then plugged in this and subtracted the 2, that's what you come up with. Now, can I divide both sides by 2 pi over 3? And once you do that, you end up with f of c equals 3 square root 3 over 2 pi. So what that says is the average height of the function on this interval is this. Where do we get that average height on the interval? Well, what you do then is you have to set the function f of x, which is cosine, equal to this. And to solve this, your answer will technically be the inverse cosine, or call it arc, also the sine negative 1, of this 3 square root 3 over 2 pi. And when you do that, your answer ends up being positive or negative 0.597. That would be your C value. I know it's x here, but it's your C value. It's the x value that gives you a certain height. Now, why is it positive or negative? Because if you look at your unit circle, both of these are on the interval. Sometimes people forget when they use a calculator to find arc, cosines, and sines. They forget the calculator is only giving you one answer, when if you think about the unit circle, there's multiple spots it could be. And there's actually two answers, and that's very easy to miss. There actually is a positive and a negative on the interval. Now, most of the time, you do these questions, you don't need your calculator arc cosine. This one did, and that's because the book had a question like that. So this are your C values that give you this height, and that height is your average height.